For more than a decade, Malaysia Airlines Flight MH370 has remained one of the greatest unsolved mysteries in modern aviation. A Boeing 777 carrying 239 people vanished from radar, leaving behind fragments of data, scattered debris, and a trail of unanswered questions that still haunt investigators, families, and aviation experts around the world. For years, the search for MH370 has relied on satellite handshakes, fuel models, drift analysis, and radar reconstructions. These methods shaped the official narrative that the aircraft most likely flew south into the remote Indian Ocean and was lost at sea. But now, a new and controversial form of evidence has entered the conversation. Not from satellites, not from radar, but from radio waves. This is the story of WSPR, Weak Signal Propagation Reporter, and how some researchers believe it may have silently recorded MH370's final journey through disturbances in global radio signals. If this technology truly captured the shadow of MH370, then the aircraft may have left behind a hidden radio fingerprint, one that could help corroborate, challenge, or even rewrite what we think we know. This is not science fiction. This is radio physics. What is WSPR and why it matters? WSPR is a global radio system used by amateur radio operators and researchers to study how weak radio signals travel around the Earth. These signals bounce off the ionosphere and travel thousands of kilometers, creating a constantly shifting web of radio paths. Under normal conditions, these radio paths are stable and predictable. But when a large object moves through certain regions of the atmosphere, it can disturb these radio paths, causing subtle changes in signal strength, timing, and propagation. Aircraft, storm systems, solar activity, and potentially a large jet flying through critical radio corridors. Some researchers now argue that MH370 may have disturbed WSPR signal paths in ways that were unknowingly recorded in global radio logs. If true, that means MH370 may have left a trail not of radar dots, but of radio anomalies. The birth of the WSPR theory. The WSPR MH370 theory did not begin inside government agencies or official investigation teams. It began with independent researchers, radio engineers, signal analysts, aviation enthusiasts, data scientists. They noticed something unusual. At times that closely matched MH370's disappearance window, certain WSPR signal paths showed unexpected disruptions along potential flight corridors. Not proof, but patterns. Patterns that some believe may align with a large aircraft moving through sensitive propagation zones. This is what they call WSPR corroboration. Not a single smoking gun, but multiple overlapping anomalies that may point to a moving object, possibly MH370. Why this matters when radar failed. Radar depends on line of sight and active systems. WSPR does not. Radio propagation can detect disturbances far beyond radar coverage. In remote oceanic regions, where radar is weak or non-existent, radio signal paths still exist. That makes WSPR potentially valuable in places where MH370 is believed to have flown. If an aircraft passed through a major radio corridor, it could have slightly altered signal paths, caused brief drops in signal strength, introduced timing irregularities, tiny changes. But across thousands of data points, patterns may emerge. That is the foundation of the WSPR argument. Corroboration, not replacement. Even supporters of the WSPR theory are careful to say one thing: WSPR does not replace satellite data. WSPR does not replace radar. WSPR does not replace wreckage. Instead, it may corroborate. It may support or challenge existing flight path models. It may help narrow search zones. It may reveal corridors of movement. In a case as cold and complex as MH370, even partial corroboration matters. The controversy: not everyone accepts WSPR as valid evidence. Many mainstream aviation experts are skeptical. They argue, WSPR was never designed to track aircraft. Radio disturbances can be caused by many factors. Correlation does not equal causation. The data can be interpreted in multiple ways. These criticisms are serious, and they are fair. But supporters respond with an equally serious point: MH370 is not a normal case. When traditional methods fail, unconventional data becomes more valuable, not as proof, but as direction. The regions of interest: some WSPR analyses suggest anomalies along corridors that overlap with alternative southern routes, western Indian Ocean paths, regions outside the original high-priority search zones. This is where WSPR becomes dangerous to the official narrative, because if radio anomalies align with areas that were never fully searched, then the case for re-evaluating assumptions becomes stronger. Not certain, but stronger. The pattern problem: one anomaly means nothing. Two anomalies mean coincidence. But repeated anomalies along a possible flight corridor raise a different kind of question. Is it noise, or is it signal? WSPR researchers argue that the frequency, timing, and location of some disruptions form patterns that are difficult to dismiss as random. Skeptics argue that with enough data, patterns can always be found. This is where the debate becomes intense, because MH370 is no longer just an aviation case. It is a data science battlefield. Why WSPR has reignited interest for families and independent investigators. WSPR represents something rare: new information. Not recycled theories, not old assumptions, but fresh data layers. In a mystery where most evidence is frozen in time, any new angle feels like progress, even if it is controversial. A hidden radio shadow: if MH370 disturbed radio signals as it flew, then it may have left behind something almost poetic: a shadow. Not visible to radar, not visible to satellites, but written into the invisible fabric of radio waves. A ghost recorded in noise. This is the idea that has captured attention, not because it is proven, but because it is possible. What comes next? In the next parts of this series, we will explore how WSPR data is collected and analyzed, specific corridors suggested by radio anomalies, how WSPR compares with satellite handshake arcs, why some experts believe WSPR could support alternative crash zones, and why others believe it is dangerously misleading. MH370 may still be lost, but its signal may not be. To understand why WSPR has become part of the MH370 discussion, we must go deeper than headlines and theories. We must go inside the data itself, into how weak radio signals are recorded, how anomalies are detected, and how researchers believe those anomalies may line up with a moving aircraft. This is not guesswork. It is signal analysis. And in the case of MH370, signal analysis may be one of the last remaining ways to extract new information from a decade-old mystery. How WSPR actually works. WSPR, or Weak Signal Propagation Reporter, is a digital radio protocol used by amateur radio operators around the world. Transmitters send extremely low-power signals that are received and logged by stations thousands of kilometers away. Each reception is automatically recorded with timestamp signal strength, frequency, transmitter, and receiver locations over time. This creates a massive global database of radio propagation paths. Under normal conditions, these paths are influenced by solar activity, ionospheric conditions, time of day, seasonal variations. But when something large and conductive moves through certain regions of the atmosphere, it can introduce subtle disturbances into these paths. This is where MH370 enters the discussion. The aircraft as a moving disturbance, a large metal aircraft like a Boeing 770, is not invisible to radio waves. It can reflect, absorb, and scatter radio energy. Researchers argue that as MH370 moved through critical propagation zones, it may have caused, Brief drops in signal strength, unexpected signal fading, timing irregularities, path deviations. These effects would be tiny, almost invisible on their own, but across many paths and many timestamps, they may form a moving pattern, a pattern that looks like an aircraft track. Turning noise into patterns. One of the hardest problems in WSPR analysis is separating noise from meaning. The radio environment is chaotic. Solar flares, geomagnetic storms, weather systems, ionospheric turbulence. All of these can disturb signals. So researchers use filtering techniques to remove known solar effects, compare against control days, look for synchronized anomalies, track movement across multiple paths. The goal is not to find one spike, the goal is to find a trail. The timing correlation, one of the reasons WSPR gained attention in the MH370 case, is timing. Some reported WSPR anomalies appear during windows that align with loss of transponder, satellite handshake periods, estimated cruise segments, estimated final flight hours. This does not prove anything, but timing matters in forensic analysis. When independent systems show disturbances at the same times, investigators take notice, even if they remain skeptical. Suggested corridors. Some WSPR-based models suggest corridors that loosely align with Southern Indian Ocean routes, western deviation possibilities, alternative arcs outside original high-priority zones. These corridors are not precise tracks, they are probability bands. They suggest where a moving disturbance may have traveled. Critics argue these bands are too wide to be useful. Supporters argue they are still narrower than millions of square kilometers. In a case like MH370, narrowing matters. The debate over resolution. One of the biggest criticisms of WSPR is resolution. WSPR cannot pinpoint an aircraft to a specific kilometer. It cannot tell altitude. It cannot tell aircraft type. At best, it can suggest that something large may have moved through a region at a certain time. That makes it dangerous to overinterpret. But supporters counter with this: MH370 does not require perfection. It requires direction. If WSPR can reduce the search area by even a small percentage, it becomes valuable. Independent verification efforts. Some independent researchers have tried to verify WSPR findings using different datasets, different filtering methods, different statistical approaches. Results vary. Some see patterns, some see randomness. This disagreement is at the heart of the controversy. WSPR is not accepted science in aviation investigation, but it is not dismissed either. It sits in a gray zone, a zone where new ideas live. Why governments have not adopted WSPR? Official investigation teams rely on validated, standardized methods. WSPR is experimental in this context. Using it officially would require peer-reviewed validation, repeatable results, clear causation links. So far, WSPR has not met that bar. But unofficially, analysts still look. Because unofficial tools have solved cold cases before. The power of corroboration. The key word is not tracking, it is corroboration. If WSPR anomalies line up with satellite handshake arcs, drift model backtracking, independent radar reconstructions, then confidence grows. Not certainty, confidence. This layered approach is how complex mysteries are sometimes solved. Not with one breakthrough, but with many small alignments. The risk of false hope for families. WSPR is emotionally dangerous. New data brings hope, but hope can hurt. Researchers are careful, or should be careful, not to oversell. Because in MH370, false certainty has already caused deep pain. WSPR must be treated as a tool, not as an answer. A new kind of trail. If MH370 did leave a radio disturbance trail, then it left something unique, not wreckage, not debris, not radar dots, but a pattern written into the physics of the atmosphere. A trail that only exists in data. A trail that may still be waiting to be fully understood. By now it is clear that WSPR is not being presented as a replacement for satellite data or traditional investigation tools. Instead, its supporters argue that WSPR may help identify zones of interest, broad regions where radio signal disturbances appear to align with the possible movement of MH370. To understand this, we must compare two very different types of evidence: satellite handshake arcs and radio propagation anomalies. Both are indirect, both are incomplete, but together they may tell a more complex story. Understanding the satellite. Arcs: the satellite handshake data from Inmarsat produced arcs, curved lines showing where the aircraft could have been at specific times. These arcs do not show direction, they do not show altitude, they only show distance from the satellite. Investigators used fuel models and speed assumptions to project a southern route. That became the foundation of the official search zones. But the arcs themselves allow for multiple paths. This is where alternative interpretations enter. Where WSPR and satellite data overlap, some WSPR researchers claim that clusters of radio anomalies appear in regions that intersect with portions of these arcs, particularly in areas that were not heavily searched or were deprioritized early in the investigation. These overlapping regions are what supporters call corroboration zones. Not proof zones, not crash sites, but areas where two independent systems show unusual alignment. This is significant because it reduces the chance that both systems are pointing randomly, at least in theory. The Southern Corridor question, one of the strongest WSPR claims, involves sections of the Southern Indian Ocean Corridor. WSPR anomalies reported in these regions appear, according to supporters, to track a moving disturbance roughly consistent with long-haul cruise speeds. If interpreted as an aircraft, the timing loosely matches satellite handshake intervals. Skeptics argue that this could also match ionospheric variability. Supporters argue that the movement pattern is too structured to be purely atmospheric. This is where interpretation becomes critical. Western deviation possibilities more controversial are WSPR analyses that suggest possible western or northwestern deviations before a final southern turn. These models imply that MH370 may have flown through regions that were only lightly searched or not searched at all. If true, this could help explain limited debris recovery uncertainty in drift models, gaps in radar reconstruction. However, these Western deviation models are among the most disputed. They challenge long-held assumptions, and in aviation investigation, challenging assumptions is always difficult. The question of timing windows, WSPR anomalies, are often clustered into time windows that roughly correspond with loss of civilian radar, military radar handoff zones, later satellite handshake intervals. Supporters argue that this clustering suggests a moving object rather than random noise. Critics argue that clustering can occur naturally in ionospheric data. The truth may lie somewhere in between. But timing correlation is one of the strongest arguments WSPR supporters make. Why these zones matter, even if WSPR is only partially correct, the idea of zones matters, because search operations are about probability. You do not search everywhere, you search where the odds are highest. If WSPR can shift those odds, even slightly, it becomes relevant, not decisive, relevant. Search areas that were never fully explored. Some proposed WSPR zones fall outside the most intensively scanned areas of the southern Indian Ocean. These regions were deprioritized due to fuel exhaustion assumptions, simplified speed models, confidence in satellite arc interpretation. If those assumptions were even slightly wrong, entire zones could have been missed. This is one of the most powerful implications of WSPR, not that it proves a new crash site, but that it highlights where assumptions may have narrowed the search too early. The risk of confirmation bias. A major danger in WSPR analysis is confirmation bias. Researchers may unconsciously look for patterns that fit what they already believe. This is why independent replication is critical. Some independent analysts see similar zones, others do not. This inconsistency is one of the reasons WSPR remains controversial. The layered evidence approach. Modern cold case investigations increasingly rely on layered evidence. No single data source is trusted completely. Instead, investigators look for alignment across satellite data, radar reconstruction, debris drift, modeling radio anomalies. Human Witness Reports WSPR in this framework becomes one layer, not the foundation, but a possible support beam. A map written in noise. If WSPR anomalies truly reflect a moving aircraft, then MH370 may have left behind a kind of invisible map, not drawn in ink, not drawn on radar, but written in noise, a map that is blurred, a map that is debated, but a map that may still hold clues. The stakes of getting it wrong. If WSPR zones are wrong, then pursuing them wastes time, money, and emotional energy. If they are right, even partially, then ignoring them could mean the wreckage is sitting in a region never seriously examined. That is why this debate matters. It is not academic, it is practical. A case still in motion. MH370 is not frozen in time. New methods, new models, new interpretations. WSPR is part of that evolution, not because it is proven, but because the mystery demands new thinking. As WSPR analysis gains attention in the MH370 community, it has also attracted strong criticism from aviation investigators, statisticians, radio engineers, and scientific reviewers. These critics do not dismiss the mystery of MH370, but they do question whether WSPR is a reliable tool for solving it. Understanding these criticisms is essential, not to shut down new ideas, but to separate possibility from probability. The core scientific objection. The most fundamental criticism is simple. WSPR was never designed to track aircraft. It was designed to study radio propagation. Using it to infer aircraft movement is an unintended use. In science, unintended use can sometimes lead to breakthroughs, but it can also lead to false conclusions. Critics argue that WSPR data is too indirect to support strong claims. The problem of causation. Just because a radio anomaly occurs does not mean an aircraft caused it. Radio propagation is affected by solar flares, geomagnetic storms, ionospheric tides, atmospheric waves, weather systems. These effects can create patterns that look structured. In statistics, this is dangerous, because humans are very good at seeing meaning in noise. Critics argue that many WSPR anomalies attributed to MH370 could be fully explained by natural ionospheric behavior. The multiple comparisons trap. Another major statistical concern is known as the multiple comparisons problem. When you analyze massive datasets and look for patterns, you will always find some, even if nothing meaningful is happening. If researchers test enough combinations of times, paths, frequencies, regions, some will appear to line up by chance. Critics argue that without strict statistical controls, WSPR findings may be artifacts of data mining rather than real signals. Reproducibility concerns. In serious scientific analysis, results must be reproducible. Different analysts should be able to use the same data and reach similar conclusions. In the WSPR MH370 debate, reproducibility has been inconsistent. Some researchers see strong patterns, others see weak or no patterns. This inconsistency undermines confidence. Critics say this suggests that interpretation plays too large a role. The risk of narrative fitting. Another criticism is narrative fitting. Once a story exists, such as MH370 flying a particular route, analysts may unconsciously fit data to that story. This is not dishonesty. It is human psychology. But in forensic analysis, it can be deadly to accuracy. Critics argue that some WSPR interpretations appear to be guided more by expectations than by blind analysis. Why official investigators stay away. Government and official accident investigation bodies are extremely cautious. They rely on methods that have clear physical causation, strong validation, historical precedent, legal defensibility. WSPR does not yet meet these standards. Using WSPR officially would expose investigators to criticism and legal challenges. That is one reason why no official MH370 investigation has adopted WSPR as a core tool. The fear of false hope. Perhaps the most sensitive criticism involves families. New theories can create new hope. Hope can become pain. If WSPR raises expectations and then fails, families may experience another wave of loss. Some critics argue that researchers have a moral responsibility to be extremely careful with how WSPR findings are presented, not as breakthroughs, but as experiments. Supporters push back. WSPR supporters respond with their own arguments. They say MH370 is not a normal case. Traditional tools have failed. New ideas are necessary. Unconventional data has solved cases before. They argue that skepticism is healthy, but dismissal is dangerous. The middle ground. Some experts take a middle position. They do not accept WSPR as proof, but they do not reject it entirely. They see WSPR as a hypothesis generator, a tool for suggesting new zones, a way to challenge assumptions. In this view, WSPR is not evidence, it is a question generator. Why this debate matters? This is not just a technical argument. It affects real decisions: search funding, search locations, public trust, family expectations. If WSPR is wrong, resources could be wasted. If WSPR is right, resources could be misdirected if it is ignored. The cost of being wrong is high on both sides. A case that forces new thinking. MH370 has already broken many assumptions in aviation investigation. Never before has a large commercial aircraft disappeared so completely. That reality makes room for unconventional thinking. But unconventional thinking must still meet scientific discipline. This is the tension at the heart of WSPR. A tool on trial in the court of public opinion, WSPR is on trial. Supporters argue it deserves serious attention. Critics argue it is not ready. The verdict is not in. And until it is, WSPR will remain one of the most controversial ideas in the MH370 search. After years of satellite analysis, radar reconstruction, debris modeling, and failed deep-sea searches, the MH370 mystery remains unresolved. WSPR has entered this story not as a solution, but as a challenge to the idea that all useful data has already been exhausted. The final question is not whether WSPR proves what happened. The final question is whether WSPR is good enough to justify looking again. What a WSPR-guided search would mean. A WSPR-guided search would not replace traditional methods. It would layer on top of them. Investigators could compare WSPR zones with satellite arcs, overlay drift, backtracking models, cross-check with independent radar reconstructions, identify overlapping high-probability areas. The goal would not be certainty. The goal would be probability stacking, finding where multiple imperfect tools point to the same place. That is how modern cold cases are sometimes solved. Why a small targeted search matters. Large-scale searches are politically and financially difficult. But a small targeted search is different. If WSPR can help define even a moderately smaller zone, it could make private funding more realistic, government support easier to justify, new technology more affordable to deploy. Instead of searching millions of square kilometers, investigators could focus on specific corridors or clusters. This changes the economics of the search. The technology is better now. Since the original MH370 searches, deep-sea technology has improved. Modern AUVs can scan faster, scan deeper, use higher resolution sonar, use AI-assisted object recognition. What was impossible or too expensive 10 years ago is now more realistic. If a new search is launched, it will not look like the old ones. It will be smarter. The political reality: even with new ideas, politics still matters. Governments must balance cost, public interest, diplomatic relationships, national security concerns. WSPR alone is unlikely to force a government to act, but WSPR combined with public pressure, independent funding, new analysis of old data could shift the conversation, not quickly, but gradually. The families and the weight of uncertainty for families. The question is simple: is there a reasonable chance this could help? They do not demand certainty. They ask for effort. WSPR offers something rare in this case: a sense that the data story is not finished, that there may still be something new to learn. The legacy of WSPR and MH370. Even if WSPR never leads directly to wreckage, it may still change how future investigations are done. It expands the idea of what counts as evidence. It reminds investigators that indirect systems can sometimes reveal what direct systems miss. In that sense, WSPR's legacy may go beyond MH370. The final balance: WSPR is not proof. WSPR is not nonsense. It sits in between, a hypothesis, a tool, a challenge. In a case as unique as MH370, even tools in the gray zone deserve careful, critical attention. Not blind belief, not automatic rejection. The mystery that demands humility, MH370, has taught the world humility. Satellites failed to give certainty. Radar failed to give closure. Search ships failed to find the wreckage. WSPR may fail too. But the greater failure would be to assume that no new path is worth exploring. The last signal, if MH370 truly disturbed radio signals as it crossed the sky, then it left behind something extraordinary. Not a voice recording, not a final message, but a physical trace in the invisible world of radio waves. A last signal. Whether that signal is real or imagined is still debated. But the fact that we are still listening means the story is not over.